So I'm just going to give you a couple more of these examples, and I'm just looking at some that maybe are a little bit confusing. In this next section, they're talking about find all solutions on the interval from 0 to 2 pi. So do pay attention to like what your interval is when you're doing these, so you can get the answers right. You know, on this one, we got two different functions which we can deal with. Like if you remember the first problem from the first video, but ideally we only have one. And you know, I'm looking at this, and you know, I know that the Pythagorean identity involving sine squared has cosine squared in it, and that would be a nice way to get to just a cosine, because then we could do a factoring move. And then, you know, I see that this also has a 2 and a 2, so this is going to be able to be manipulated a little bit. Now, that's just experience, and, you know, just you got to try some things out. But that's what I think of, you know, sine squared plus cosine, sine squared plus cosine squared equals 1. So the first step I'm going to do, and you know, maybe this doesn't work out, but I'm going to subtract this term over here and subtract this term over here at the same time, just to save a little room. So then I have negative cosine of x equals 2 minus 2 sine squared of x. And then I'm going to take a 2 out. Because I know 1 minus sine squared is cosine squared. Okay, and I guess there was no need for me to move the cosine x to the left-hand side, because now I'm just going to add it back to the other side, but it seemed right at the time. And now this is a much more manageable problem, because we only have cosine. Even though we have a cosine squared in there, we're going to be able to take care of that by factoring. So I'm going to take a cosine out, and we left with 2 cosine plus 1. Now we have two factors that we can set equal to 0. And we're going to solve both of these. Let's just do the cosine of x equals 0, 1. You know, let's go up and look at our unit circle. All right, so cosine again is x, so where is x 0? X is 0 here and here. So on this case, you know, we're only answering from 0 to 2 pi, so there's only two answers. So one of them is pi over 2, and the other one is 3 pi over 2. Both of those give you a 0. So we know that that's an answer, and also this is an answer. Okay, and so then on the other equation, we're going to have 2 cosine of x equals negative 1, and cosine of x equals negative 1/2. So again, let's take a look at our unit circle, right? What angle, when we take the cosine of it, gives us negative 1/2. So we're going around, and our x value is negative 1/2 here at 2 pi over 3, and then again at 4 pi over 3. So those are our other two answers, 2 pi over 3 and 4 pi over 3. And again, we don't need to add the, you know, that extra little thing, because we're only going around from 0 to 2 pi there. Okay, so maybe a little intimidating here at the first glance, but really this is just a factoring problem. And so, you know, if you can factor this, then factoring this, these two are the exact same thing. Just instead of x, we have a sine. So I'm going to set it up like this. This one's a pretty straightforward one. There's only so many factors that it could be. And so then, right, that works out. If you need to FOIL it, that's a good idea. But now we have two factors, and so now we can set both of those equal to 0. So then 2 sine of x plus 1 equals 0, and sine of x plus 1 equals 0. So then we're looking at sine of x equaling -1, and sine of x equaling -1/2. And again, remember we're on 0 to 2 pi, so we don't need everything here. So let's look at where sine, what angle gives us a sine. Let me re-say that. When we take the sine of what angle do we get -1/2? Okay, so again, sines are y's. So where is the y value? -1/2. Not there. Right? Not there. Not right there. Okay, so right, 7 pi over 6, and then also 11 pi over 6. Okay, and then we're going to look for the angle. When we take the sine of that angle, gives us -1. Again, we're looking at y values. So we come up, that's a +1, -1, and so x also could be 3 pi over 2. Okay, so there's a lot going on in this problem, and my first instinct was to factor something out of this so that I could get some of these to cancel away. Now the problem with doing that is this is not a 0, and so even if I could factor something out and get something nice and simple, that doesn't do us any good because of this 2. And so if we subtracted 2 over here to set it equal to 0, that still gets us nowhere really, because that doesn't factor real easily. So do remember all your rules. If you're trying to factor, you do need it set equal to 0. So the thing I think here would be to see if we can combine these two in some way, and so that's what I'm going to try. We're going to leave this one alone for a second. And since tangent is sine over cosine, we can rewrite this as sine squared of x over cosine. And so now we could get a common denominator of cosine, and that would mean that this is cosine squared of x over cosine of x plus sine squared of x over cosine of x. And this is looking pretty right now. Again, maybe you don't see that right off the bat, but this you got to just try some things out until you get more comfortable with it. And the reason I think this is looking really pretty right now is that we've set this up as a Pythagorean identity, so that's going to be 1. And so we've gone from 3 different trig functions all the way down to, on this next step, 1. So that's a pretty good move. So then that would be 1 over cosine of x equals 2. And you could totally change that into secant. I don't like dealing with secants and cosecants and cotangents if I don't have to. So I'm going to multiply by cosine and then divide by 2. And so now all I'm looking for is an angle that when I take the cosine of it, I get 1/2. And that seems a lot easier to me than dealing with a secant. But you can do it either way. You know, if you got the unit circle memorized really well, then go for it, you know. Again, we're still on 0 to 2 pi. We're looking for where cosine equals 1/2. That means where our x value is 1/2. So we get to pi over 3. And we have to go all the way around to 5 pi over 3 for our other value. So hopefully that gets you in a good place for that 25 to 40 section. You know, there's a lot of things going on. You got to factor and try some different things out. And then the rest of the section is a lot of using the graphing calculator to estimate some things, and there's some word problems. So, you know, if you're getting mixed up on something, you know, you really need to go ahead and post something to Google Hangout or email me so that I can help you out if you're getting mixed up.